Oh, our audio is going through. Oh, hi everyone. Can you hear us? Hi. Welcome to the live solve. Your co-hosts here are me. My name is Vivian, and my co-host.
Hi guys, my name is Haley, and I have the honor of co-hosting with Vivian. And Vivian's really cool, and she'll show you guys how to do a lot of these problems, but she's really good at math. So a few cool things about Vivian is that she's qualified for the USA Math Olympiad program, which is really prestigious. And she's also on the four-person US team to the 2022 and 2023 European Girls Math Olympiad, which is really, really cool.
Thanks. And Haley is also super cool. She's a high schooler from Florida who's really good at math. She qualified for Amy 3 times and qualified for Math Prize for Girls too. And she's an officer on her high school math team and loves introducing others to competition math. And in her free time, she likes to cook and listen to music. So she's a super cool person. Now, I think someone from Math Kangaroo is going to give a little intro about Math Kangaroo.
Yeah, so hi guys, my name is Samar Das. I'm excited to be here with you today. I'm a longtime participant of Math Kangaroo. Math Kangaroo is a very interesting math competition that includes math and logic problems for all grades from kindergarten to 12th. So I'm also a teacher assistant to help kids like you guys learn and enjoy math, which is what we'll be doing in today's session. So Math Kangaroo is like a really interesting competition, which you can participate in whenever you want. And I highly encourage you to do it next year after participating in this session today. So yeah, thank you. I'll hand it off to the co-host.
Okay, yeah, thank you. So, all right, wait. I hope you can see my screen, but you may have noticed there's something called chat relay in the Zoom meeting. So if you like direct message chat relay by going into chat and then selecting chat relay from the drop-down menu, you can send us messages and then they will show up on our screens in like this little rectangle on the bottom. So maybe if all of you could practice that by writing in chat relay like where you're from, like what part of the world, then we can see where all of you guys are from. And they should show up on our screens. So throughout this whole thing, if you want to like say something, like an answer to a question or a comment or anything, just message chat relay and then it'll show up on our screens. Wow, you guys are from all sorts of different places. Wow, we've got some people from America, some people from China. Wow, all over America. That's really cool.
Yeah, I've seen like some common states too, like Maryland. I've seen Texas twice, which is pretty cool. And I've also seen China a lot, which is really neat since the time is different, right? You guys are in the morning, which is pretty cool.
Yeah, that's cool. Also, just wondering, what grades are you guys in? Because this Math Kangaroo thing is, so this test was for grades 3 and 4. So I'm wondering, like, are you guys in 3rd or 4th grade? Younger than that? Older than that? Oh, wow, 3rd grade. You guys are so young. Wow.
Whoa, there's a first grader.
Oh my
Wow.
God.
That's a
Wow. And
really, oh, that's a good way to get a head start on math. Do some Math
yeah,
Kangaroo. Mhm.
yeah, you guys are getting a very early head start on math. Wow. And you guys can also all type. Wow, I'm impressed. When I was in 5th grade, I don't know if I knew how to type.
Yeah, wait, my little sister is in third grade and she definitely cannot type. So
Wait,
that's
I
pretty cool.
I have a sister in 3rd grade too, and she actually does know how to type.
Oh,
But
wow.
but I don't know if I did when I was in 3rd grade.
Mm.
Oh, Pippin, your mom types for you. That's very nice of her. Hmm. Wow, lots of 3rd graders and lots of California people, it looks like. Oh, wow, that's cool. And some 4th graders too. Wow. Well, I guess that makes sense because this was for 3rd and 4th grade.
Mhm.
Ooh,
Wow, so
wow.
you guys are from all over the world and a few different grades. So that's pretty cool. And it's also really great that a lot of you guys are interacting in the chat because that's really helpful.
Yeah, that's great. Definitely keep that up. If you want to like share your solutions to any problems or just any ideas about them, definitely put your ideas in chat.
Mhm.
Okay, well, with that, I think we can get started with the problems. By the way, me and Haley haven't seen the problems yet, so we'll kind of be talking through like our thought processes when seeing the problems and like what ideas we have about them. But you guys can feel free to put any of your ideas out there too. So we're just going to be alternating. Haley, do you want to start first?
Yeah, so okay, we have our first question over here. And we have this very cool puzzle. Okay, it looks like tiles, like a bathroom tile, like a very fancy bathroom tile. If you ever wanted to interior design your home nicely, you might choose these tiles. But we want to complete the puzzle so that these things, these little symbols match in each of the corners. So I see like a round thing here. So I'm thinking in the upper left, I want a round thing. So I'm going to get rid of answer choices A and D. Oh, and I see a lot of people are putting in answers, which is really cool. Okay, and then I'm going to look at the upper right now. So I see a spiky thing. So I want a spiky thing in the upper right-hand corner. So I'm going to get rid of C. And then now I'm going to look at the lower right-hand corner. So it's like curved like this. And so it looks like B isn't right either. So it looks like E is probably our answer choice. All right, let's check. Oh, that's just another picture. Okay, yay, we got it. Our answer choice is E. Good job, guys.
Yay, awesome. Yeah, that was a cute little problem. And it looks like a lot of you agree, so that's great. Okay, moving on to the next problem. These are pretty cool. Okay. So, more diagrams. Let's see. So we want which of the figures has the largest part shaded. So I'm assuming that's the green part. Okay, let's see. Looks like they all have like quite a bit shaded. So maybe it would be easier to find like how much of each of them is not shaded because it seems like most of it is shaded. So maybe if we find like the white area, that will be the part that's not shaded and maybe we can compare that. So let's just write on each diagram like how much of it is white or like not shaded. In the first diagram, it looks like we have one, wait, let's do a better color. We have 1 square, 2 square, and then these two triangles kind of combine to form a third square. So diagram A has 3 like non-shaded. Oh, wow, looks like a lot of you are saying A in chat. So I guess you're saying A has the largest part shaded or the least part not shaded. So maybe I'll just write like largest part shaded equals smallest part unshaded. Okay, so yeah, let's just go through the other diagrams too to see how much they have not shaded. So it looks like B has like 3, but then a little bit extra, which is half. So B has 3.5 unshaded. And then C, okay, looks like C also has like 3.5 since 1, 2, 2.5, 3, 3.5. So C also has 3.5 unshaded. Yeah, I can see your chat here. I can see all of you guys writing A in chat. It looks like you guys are very excited about A. Okay, and then D also has 3.5 unshaded. 1, 2, 3, 3.5. And E has, okay, let's see, lots of triangles. 0.5, 1, 1.5, 2, 2.5, 3, 3.5. Okay, so it looks like they all have 3.5 squares unshaded, except for the first one, which has only 3 unshaded. So that means the first one should have the most part shaded. Wow, great job, everyone. I think the answer is A because You guys are all saying A, so it's probably A. And it is A. Yay, good job.
Oh, nice. Using complementary counting kind of is a pretty cool strategy because counting a lot of the green squares would probably take a lot more time and be a lot more annoying. So looking for a more clever solution was really cool. Okay, next question. We have Eli draws a big square on the chalk with chalk on a pavement, and then she starts on the square marked with the number 1. Okay, so she's on number 1, and then she jumps, and each time she jumps, she'll always land on a number that is 3 more than the number she is standing on. So we want to find the largest number that Ellie can jump to. Okay, so wow. I'm just gonna start adding 3 to the number that Ellie's on to see which number she can get to. So from 1, she can get to 4 only because 5 is not 3 more than 1. So we're on 4 now. And then from 4, we can get to 7, and then 10. And then here we can only get to 13. And we want to go to 13 because we want to get on a big number. So we always want to increase. And then from 13 to 16, and then 16 to 19. Okay, from 19, there's 23, but that's 4 more than 19. And there's also 21, but that's 2 more than 19. So it seems like we're stuck. And it also seems like we couldn't have taken a different path because there's never an alternative value that's 3 more than any of the values we had. So seems like the answer is 19, and it's great because all of you guys are saying 19 as well. So yeah, and I like that Luca actually put an explanation, which is really cool. So yeah, looks like the answer is 19.
Yeah, great job, everyone. Yeah, it seems like 22 is just not in the grid at all, so it's kind of impossible to get to 22. So 19 must be the biggest. Okay, cool. On to the next problem. We're rolling right along. Okay. Ooh, we have some pieces to play with. So let's see. We have 7 pieces, and we want to use some of them to cover the grid completely without overlap. And we want to use as many different pieces as possible. So how many pieces can we use? Okay, first of all, it looks like we only have 1 of each piece, so we can't like use the small one many times. Okay, let's see. So first of all, how long are each of the pieces? Maybe let's write like how big they are. So we have a square, which is 1 by 1, and then we have a 1 by 2 rectangle. We have a 1 by 3 rectangle. We have a 1 by 4 rectangle. We have 1 by 5 rectangle. 1, 2, 3, 4. And we also have, okay, this drawing is going to get a little bit challenging, so excuse my drawings, but we have a 1 by 6 rectangle and we have a 1 by 7 rectangle. Oh, okay, so they're just 1 by 1 through 1 by 7. Okay, so we have these 7 rectangles, and let's see, how long is the rectangle we want to tile? Oh, Jimmy says it's 17 squares, so I'm just going to believe you. 1 by 17. So basically what this means is, let's see, like, let's take an example tiling maybe. Maybe we first use the 1 by 4 rectangle like that. This is just a random tiling. And then maybe we use the 1 by 5 rectangle like that. So that's 9 squares already. And then maybe we use the 1 by 3 rectangle. Okay, that's 12 squares. And then, okay, wait. Okay, that was actually a bad idea. Do something else. So we do the 1 by 5 rectangle, and then maybe, okay, how many squares are there left? 8 squares, and then maybe we use the 1 by 2 rectangle and then the 1 by 6 rectangle. So this is like an example tiling. And as you can see, in this example tiling, we first used the 1 by 4, and then we used the 1 by 5. By the way, order doesn't matter. And then we used the 1 by 2, and then we used the 1 by 6. But something cool about these 4 tiles are that if you add up their lengths, you get 17. So 4 plus 5 plus 2 plus 6 equals 17. So basically, in all our tiles, their lengths just need to add to 17. So basically, we just want like the biggest number of numbers from 1 through 7, distinct numbers that we can add to get exactly 17. Oh wow, okay, lots of you are saying C. So let's see if I agree with that. C is 5. Okay, let's see. So because we liked small tiles, maybe if we want to use as many tiles as possible, we can just like start with using the 1 by 1 and then like use the 1 by 2 right after that, and then maybe use the 1 by 3 right after that. And then just like keep on going like that so that we can make sure that we use as many small tiles as possible. And by the way, these are like the lengths of the tiles right here. So anyway, we would get 1 plus 2 plus 3 plus 4 plus 5. Okay, how long is that? I think that's 15. But that's not exactly what we want because we wanted 17. But we can adjust this a little bit by replacing 5 with 7. So if instead of plus 5, we did plus 7, we would get 17. Okay, cool. So we now know that it's possible with 5 tiles. We can use 1, 2, 3, 4, and 7. So the answer is at least 5. Now the question is it possible to do it with 6 tiles? So is 6 possible? We know that 5 is possible, but is 6 possible? It looks like a lot of you in chat were saying that if we used 6 tiles, somehow it would be like too long. So let's see what would happen. If we tried to use 6 tiles, I mean, the easiest way, like the way to make the shortest possible distance with 6 tiles is take the smallest 6, but then we would get 1 plus 2 plus 3 plus 4 plus 5 plus 6 for the length, which is 21, which is longer than we need. So actually 6 is not possible because it's not possible to make only 17 but use 6 tiles. So then the answer must be 5. And a lot of you are saying 1, 2, 3, 4, 7 in chat, which is great. 1, 2, 3, 5, 7 is one of the ways. Wait, actually, I think it's the only way actually. Wait, no, actually, there's another way. You can also have like 1, 2, 3, 5, 6. Wait, is that true? Yeah, 5, 6. So there's actually like 2 ways to do it with 5 tiles, like 2 different combinations of 5 tiles. But either way, the answer is 5 because it's not possible to use more than 5 tiles. Okay, great job, everyone. Let's see, it's probably correct. And yay, it is. Okay, good job.
Wow, that was a very thorough explanation. And it's also really good to be thorough because then you can be sure that you're right. Because you don't want to see a possible answer but not find what the question is looking for, which is the greatest number of tiles. So that was really cool. Okay, now we have a question about a pyramid. Lowe's looks at the pyramid from above, and what does Lowe's see? Okay, so this seems like a question where the orientation of the sides on the pyramid matters, because this is probably maybe a bit hard to see, but in the back we have 2 of like the same colored sides, so I'll just color them green. And then we have 1 in the front over here that's purple. And then we have 1 over here and the red. Oh, okay, you guys could see the colors already. Sorry, maybe I'll just get rid of those then, because all of the answer choices are also colored like this. Okay, so I'm thinking, first of all, I see the 2 only gray sides are right next to each other. So in the answer choices, I'm going to look for where the 2 gray sides are right next to each other. So, well, for answer choice A, there aren't even 2 gray sides, I think. There's 2 white sides, so it's not answer choice A. Answer choice B does have 2 gray sides, but they're opposite of each other, which is bad because we want them to be next to each other. So that's also bad. Answer choice C does have the 2 gray sides next to each other, and so does answer choice D. And answer choice E is like answer choice A in that it only has 1 gray side, so that's bad. But now looking at the difference between answer choice C and D, it seems like it's the order of how the sides are going. So here, if we imagine we looked at the top and we had to like rotate it, we see that this, okay, let me just write this square if we were to like flip it like this. So, oh, that was a bad square. So if we have the gray side, I'm just gonna say the gray side is orange. It would be like this. And then the white side with a black line through it, I'm going to use blue. And then the white side, I'm going to use purple. So it'll look like this. And then we have to see if we rotate it, if it would look like C or D. And for C, it looks like these two are the orange sides. And then this is the blue side. And then this is the purple side. So it looks like if we rotated our square 180 degrees, we would get to C. So it seems like C is the right answer choice. And it seems like Lowe's is looking from the other side, so like this way on. Oh, okay, wait, there's actually some controversy on whether it's C or D, but I feel like the answer choice that's correct is C. So let's see, oh, that's a pun. Let's see what the right answer is. Oh, okay, it looks like it is C. But yeah,
Nice.
that was maybe a bit confusing because of rotating.
Nice. Yeah, this was a very complicated problem. Choices C and D, like both look like they could be the correct answer. At least the other ones like don't look so much like that. And I think like you have to think about like what order the different color sides would be in. So it's really tricky. But yeah, good job, everyone. This was a pretty tricky problem. Okay, on to the next problem. And by the way, we're like, it looks like we're skipping problems. So this was problem 10. It looks like we skipped problem 9. Okay, let's see. What's the next one? Oh, it looks like we have problem 12. So maybe we're seeing some pattern in the even problems. Okay, so let me make this a little bigger that you can see it. Okay, there we go. Ooh, we have a fence using poles. And it looks like we have an example, which is a 4-meter long fence, and we want to know how many poles would be required to build a 10-meter long fence. Okay, that's nice. And they give us a picture so we know how to build the fence. Okay, so as you can see, the reason why like this is a 4-meter fence is because it kind of has like 4 rectangles here on the top, like 1, 2, 3, 4, and like 4 like rectangular holes on the bottom too. So it's kind of like it has length 4. And let's see, how do we build the fence? Okay, Tia's asking, what is this math question? Yeah, this is a pretty interesting question and kind of unusual too, because we don't usually get asked to like build fences. But let's see. So there's a few different parts of the fence. Maybe let's use colors to like identify them. So first of all, we have the pink part on the top. So in this example, the pink part has length 4 because it's a 4-meter long fence. But if we think about a 10-meter long fence, this pink part will be 10 meters. So, okay, well, actually, I'll just write 10 poles. So that's the pink part. And now, okay, we have some other parts too. Oh, actually, you know what? To make this a little easier, we'll include these other 4 also as part of the pink part. So now instead of just 10, we'll have 10 plus 10 horizontal poles. So basically the pink part is just the horizontal poles because as you can see, the fence has both vertical poles and horizontal poles. So the pink part is just horizontal poles. Okay, now for the vertical poles. So let's see, what color should we use? Maybe yellow. So for the vertical poles, it looks like we have 2 on the very left, and then we have another column of 2, and then we have another column of 2, and then another column of 2, and then another column of 2. And in this example, how many columns do we have? So it looks like we have 5 columns of 2 here. And actually, this is pretty like tricky because it says that it's a 4-meter long fence, but we have 5 times 2 yellow poles. And that's because like it's 4 meters long, but we need to include the endpoints too. So that's why instead of 4 times 2, it should be 5 times 2 yellow poles, or like 5 columns instead of 4. So for the yellow, which is vertical, we have actually, well, instead of 5 times 2, this time it's going to be 11 times 2 poles. The 11 being 10 plus 1, because it's like 10, except we need to include both endpoints. So that's why it is a plus 1. So that's going to be 22 poles. Okay, and now all we have to do is add up all the poles. And let's see if we get 42, because it looks like all of you guys are saying the answer is 42. So let's see. We have 20 pink plus 22 yellow. And yeah, that gives 42. So yeah, I agree with you guys. Great job. This is a pretty cute problem. Oh, okay. Luca's saying you can explain by talking about the 0 meter long fence has 1 column. Yeah, that's actually a perfect explanation. So if we wanted to imagine a 0 meter long fence, which is like a really weird thing to imagine, but it would look like this basically, like just the yellow poles. There would be no pink poles. It would just be yellow poles. And it would just be like a straight vertical column of like 2 times 1 yellow, or like 1 times 2 yellow poles. Yeah, so that's a great explanation. Thanks for that. Okay, yeah, cool. And I think the answer should be 42. Yay, it is. Yay, good job, everyone.
Oh, that was a pretty nice question. It reminds me of like maybe Lincoln logs, because you have to stack up to get higher, except it's like horizontal and not vertical. Okay, now we have a different question, but it looks like we don't get a picture this time, which is kind of sad, but it's okay. Okay, so we have the sum of 3 numbers is 50. Okay, 50, this is important number. And Karen subtracts a secret number from each of these 3 numbers, and we get 24, 13, and 7 as the results. And we want to know which of the following is one of the original 3 numbers. Okay, so these are the results. So we also are told that Karen is subtracting the same secret number from each of these 3 numbers. So when we subtract from one of these original numbers, we can imagine it as, in order to get back to the original number, as adding the same value to each of the results. So I'm going to call the unknown secret number like X. And then so we have that the 3 original numbers are 24 plus X, 13 plus X, and 7 plus X. And then we can just sum them to get our sum of 50. So if we add these, we have 24 plus 13 plus 7 is 44. So 44 plus 3x equals 50. And then it looks like we have 3x equals 6. So x equals 2. And then we want to find which of the following is one of the original 3 numbers. So these are our original numbers. So it looks like we can just plug in 2. So we have 26, 15, and 9. And then looking at our answer choices, it seems like the only answer choice that is here is 9. So it looks like 9 is our answer. And okay, it looks good because it seems like all of you guys are saying A, which is 9. So check. Oh, okay, looks like we're right. Answer choice A.
Yay, good job, everyone. Yeah, that was a nice and cute problem. Wow, people are very excited about choice A, it looks like. Okay, on to the next problem. And it looks like it's problem 16. Okay. Ooh, we have sticks now. Looks like, okay, first we had like rectangles, and then we had like logs. Now we have sticks. Okay, nice. So we have two types of sticks, short ones measuring 1 centimeter and long ones measuring 3 centimeters. With which of the combinations can we make a square without breaking or overlapping the sticks? Oh, this is really interesting. So looks like we're going to have to like somehow put sticks together to form a square. So for example, like this is just a random square. Like the stick lengths will probably not be accurate, but like it looks like basically we need to form like 4 sides. Each side is the same length, and each side will be like the sum of some sticks. So like for example, maybe we have a side of length 7 that's equal to 3 plus 3 plus 1. Basically a stick of length 3 and then another stick of length 3 and then a stick of length 1. So like that's just an example. But let's see. Okay, so we want to know which of the combinations can we make a square? Okay, this is cool. So first of all, maybe like a random observation. Oh, okay, Tia, you said you have a question. You can put your question in chat and we'll try our best to answer the question. Oh, okay. Oh, Jimmy is saying we need to figure out how many short is equal to 1 long. Okay, yeah, that seems quite useful. So it looks like since the short ones are 1 centimeter and the long ones are 3 centimeter, 1 long equals 3 short. So that's like the conversion. Okay, that seems pretty useful. Okay, so I think maybe a nice observation would be that because we need the square to have 4 sides of the same length, if we say each of the side lengths is like s, then the perimeter of the square equals 4s. So whatever combination of sticks we have, the sum of their lengths should be the perimeter, right? So sum of lengths of sticks equals perimeter equals 4s. And what that means is if the sum of the lengths is 4 times an integer, it must be a multiple of 4. So maybe we can eliminate some of these answer choices by just like finding what the sum of the lengths of the sticks is. So let's write the sum of the lengths of the sticks like to the left of each answer choice. Maybe starting with choice C, since that one looks pretty easy. If we had 6 short sticks, they would have a total length of 6 times 1, which is 6. So, all right, C would give a perimeter of 6, and that's kind of not possible. It's not possible to have 6 equal to 4 times an integer because 6 is not a multiple of 4. So that means we can eliminate choice C. Okay, what about choice E? That says 6 long. So that would be a total perimeter of 6 times 3, which is 18. 18 is also not a multiple of 4, so we can also eliminate that. Basically, we're just eliminating everything that's not a multiple of 4. Oh, and Anthony asked what was that screen. I think that was just the whiteboard like being a little glitchy, but it's fine. It's okay now. Okay, let's go on to the other choices. Looks like people are saying choice B looks good. So, all right, we'll save that one for last. What about choice A? So 5 short and 2 long. That would have a total length of 5 times 1 plus 2 times 3, which is 5 plus 6, which is 11. 11 is not a multiple of 4, so we can eliminate choice A. And then choice D, 4 short and 2 long. So that would be 4 times 1 plus 2 times 3 equals 4 plus 6 equals 10. So 10 is also unfortunately not a multiple of 4, or maybe fortunately for us. So we can eliminate choice D, and then we're left with only choice B. So, okay, this is kind of funny. We didn't actually figure out like how to make the actual square, but we just eliminated all the other choices. So the answer seems like it should be B. And I'm sure if you really wanted to, you could figure out like exactly how to make the square. If you had 3 short and 3 long, you could find the side length. I think the side length, well, you could find the perimeter, and then from there you could find the side length. So the perimeter would be, I think, 3 times 1 plus 3 times 3 equals 16. So, wait, hold on. No, that's 12. Okay, yeah, that's 12. So, okay, I think if you wanted to know how to make the square, oh, yeah, Aaron, that's a very nice way of putting it in chat. Yeah, you said it perfectly. So basically we have 3 sides that are like simply just the the things of length 3, and then the fourth side is like 3 segments of length 1. So like this is what it would look like. But yeah, seems like choice B should be correct. So let's see. Yay, it is correct. Good job, everyone.
Wow, it seems like process of elimination is always a good idea in multiple choice questions. Okay, so moving on, we have question number 18. We have 6 people who each order 1 scoop of vanilla ice cream. Or not vanilla ice cream, of ice cream. So there's 3 scoops of vanilla, 2 scoops of chocolate, and 1 scoop of lemon. And then they top the ice cream with 3 cherries, 2 wafers, and 1 chocolate chip. And we have to use 1 topping on each scoop, and no 2 ice cream desserts are the same. Okay, so we want to find which of the following combinations is not possible. Okay, so I'm thinking we have 3 cherries over here. This is a cute problem because there's little drawings. And we have to put the cherries on the ice creams, but it seems like we have to put the cherries, one of each cherry, on a different flavor, because here, let me get a better picture. Okay, yeah, we have a better picture. So it seems like we need a cherry here, here, and here, because if we were to have this ice cream, which is lemon, I think, if this cherry was on like the chocolate or the vanilla, then we would have 2 ice cream combinations that are the same, which is bad. So we don't want that to happen. So we can do that. And then for the wafer, it can be like this wafer. As long as the wafers are not both on the vanilla, it should be okay. So for example, we just put the wafers here. And then finally, we have this last thing that I forgot what it was. So we're just gonna make it a green square. So it seems like this is the only possible thing that we can do, because the wafers can't both be on the vanilla. But also I noticed that because we have to put a cherry on the lemon, we can't have anything else with lemon. So, okay, yeah, here are the answer choices back. Oh, wrong way. Okay, here are the answer choices back. And then it seems like, okay, so we can have a lot of things with cherry because we have to have things with cherry. So it seems like answer choice A and B are okay. And then we also saw that we need a chocolate with a wafer. So D is okay. And then vanilla has to have all 3 things because there's 3 vanillas. So E is also okay. But as we saw earlier, lemon can only go with a cherry because the cherry needs to go on a different flavor for each cherry. So it seems like C is the right answer and that it's impossible. Yeah, wow, there's so many people saying C. So it must be right. Let's see. Okay, looks like we're good.
Wow, nice. Yeah, this is a really interesting question. Like, first of all, it seems like there's a lot of choices to make, but actually a lot of things are forced. Okay, cool. On to the next problem. Number 20. Okay, we have some numbers written on the board from 1 through 8. Okay, so it looks like they're not on the board, but we can imagine that they're on the board. So then, oh, I see, they're covered up. So then we cover up the numbers with triangles, squares, and the circle. If we add the 4 numbers covered by the triangles, they add to 10. If you add the 3 numbers covered by the squares, they add to 2. Oh, wait, no, 20. And we want to know which number is covered by the circle. Interesting. Okay, it looks like people are already saying 6. Wow, that was fast. Okay, so first of all, what numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. And what information are we given? So we have 4 numbers under the triangles and they add to 10. So, wait, this is actually kind of interesting. 4 numbers adding to 10. That seems kind of like, 10 seems like kind of a pretty small sum for 4 numbers, right? actually, it happens that if we have 4 numbers adding to 10, there's only one way to do that. It must be 1 plus 2 plus 3 plus 4. Since 1 plus 2 plus 3 plus 4 is 10, and those are like the 4 smallest things that you can possibly choose. So the 4 numbers adding to 10 must be 1, 2, 3, and 4, which means that the numbers under the triangles must be 1, 2, 3, and 4 in some order. We don't really care what order. And then, okay, so now imagine that 1, 2, 3, and 4 are like gone. So we only have to deal with 5, 6, 7, and 8. It looks like the 3 numbers covered by the squares add to 20. All right, so 3 of these numbers, 5, 6, 7, and 8 add to 20. Oh, okay. Oh, Rohan has a good idea. And it seems like lots of people have this idea too. So basically, 5 plus 6 plus 7 plus 8 equals 20 plus the circle number. Okay, wait, that was kind of confusing because it looks like 0, but circle number. Okay, I'll write that in red, maybe it's more clear. So the reason why this is true is because the circle, well, okay, 20 is going to like take 3 of these numbers between 5, 6, 7, and 8, and then the one left over is going to be the circle number. So if we solve this equation to find the circle number, all we have to do is a little bit of addition. So 5 plus 6 plus 7 plus 8 equals, let's see, the middle two sum to 13 and the outer two also sum to 13, so that's 26. So therefore 26 equals 20 plus the circle number. So the circle number should be 6. Oh, great. And a lot of you are saying D, so that looks great. Yeah, good job, everyone. Okay, hopefully the answer is D, but I believe you guys. Awesome, it is. Thanks.
Nice. Wow, that was a really clever idea to write it out in an equation. Because I feel like usually intuition is just you try some numbers because there's only 4 numbers, but it seems like writing equation is the most sure way to get the right answer. Okay, next question is, oh, we're at a summer kangaroo camp. I wonder if we're part of that right now, even though it's not really summer. But okay, we have a summer kangaroo camp, and each team in this camp has 5 or 6 members. And we have 43 people in total. And we want to know how many teams are at this camp. Okay, so because we have 5 or 6 team members, we can probably write an equation that goes like 5a plus 6b equals 43. And A is the number of teams with 5 members, and B is the number of teams with 6 members. And looking at this, I feel like a good way to look at it is to look at the 5A part, because 5 times anything has to end in 0 or 5. So that means the 6B term needs to end in 3 or 8, so that when we subtract from 43, we're going to get something that ends in 0 or 5. So if we just list out some multiples of 6, we can get 6, 12, 18, 24, 30, ... Okay, and it seems like 18 works because 18 ends in 8. And also seems like we're never going to get something that ends in 3 because 6 is even. So if we multiply anything by 6, we'll always get an even units digit. So 18 seems like the only thing that will work. So we have B equals 3, and then 43 minus 18 is 25. So A equals 5. And then we just need to sum A and B to get H. Yeah. Seems like a lot of people are putting in D, and Aaron, I think, did this exact process. So seems good. Okay. Let's see. Yeah, our answer is D, 8.
Okay, awesome. Yeah, that was a really interesting question. Okay, just since we have like quite a bit of time, another way to do it would be like, what if we just tried to give like all the teams 5 members And there would be some extra members, but let's just try to make as many teams as possible and give them each 5 members. So since we have 43 people in total, the maximum number of teams we can make is 8, since 5 times 8 is 40, and then we would have 3 extra people. So basically we just add an extra person to 3 of those 8 teams to make them 6-person teams, and we end with something that looks like 6, 6, 6, 5, 5, 5, 5, 5 for the number of people on each team. But basically there's 8 teams in total. So that's like another way that you could think of it. But yeah, the answer is 8. So either equations or like any other method too would definitely work. Okay, on to the last question. Actually, this is the last question that we have planned for today, because I guess we did not expect to like go through the problems this fast. But yeah, you guys are doing a great job like helping us out in chat. So we really appreciate you for that. Okay. Oh, and it looks like Rohan said subtract 6 until you get a multiple of 5, then divide by 5. Oh, that's also a really cool idea. Yeah, if we have 43 people in total, we could like we know it must be the sum of a multiple of 5 and a multiple of 6. So we could kind of just like guess and check kind of to figure out which multiples those would have to be. Okay, awesome. Anyway, last question for today. It looks like it's number 24, so probably on the more difficult end. Okay, so we have a calculation. Oh, this type of problem. So we have something that looks like we have a 3-digit number, KAN, plus a 2-digit number, GA, where all of these numbers stand for digits, and then we're subtracting a 3-digit number, ROO. Oh, this is a very interesting math problem. And then we get, okay, it doesn't tell us what we get, but it tells us that that the same letters are replaced with the same numbers and different letters by different numbers. Okay. Oh, and we want the largest possible result. Okay. So we just want like the maximum possible number that we can get when we add GA and then, sorry, wait, I typoed. It should be plus GA minus ROO. So yeah, that's pretty important. So let me make that clear. It should be plus GA and then minus ROO. Okay, wow. Oh, it seems like, okay, people are talking about like, is it mod 3? Let me see, what exactly are you guys saying? Oh, okay, so interesting. Okay. Oh, so people are saying B and D. Oh, interesting. People have some cool ideas on this one. Rohan's saying ROO should be small. Okay, yeah, that makes sense. If we want the answer to be maximum, we don't want to subtract a ton. So we want ROO to be kind of small. And similarly, we also want, okay, ignore the fact that M has 3 humps. But yeah, and then we also want KAN and GA to be pretty big since we're adding them together. Okay, and so basically all we have to do is assign different numbers to different letters. So we're going to have like K equals something, A equals something, N equals something, G equals something, R equals something, and O equals something. By the way, O is not 0, even though it looks really confusing. Okay, oh, awesome. Aaron's saying that the smallest possible ROO is 1, 2, 2. Okay, let's see. So maybe would it be a good idea to set R equal to 1, 2, 2? And by the way, the reason why that's the smallest is because we can only use the digits 1 through 9, and we can't use the same digit twice. So like R and O have to be different digits. And so we want to make R, well, R is like our first priority for being small because R corresponds to a hundreds number. So like R matters a lot. So we want to make R the smallest possible number, which is 1. And then the next smallest possible number for O would be 2. So yeah, the smallest possible R is 1, 2, 2. Okay. And I think that makes sense. Like I think it's a pretty good idea to make R small because also we want KAN and GA to be as big as possible. So like we're not going to use any 1s or 2s for like KAN or GA because we want to use big digits, not small digits. So I think it makes a lot of sense to set R. Oh wait, oops. this is kind of confusing. I meant to write R equals 1, O equals 2. So yeah, but anyway, ROO equals 1, 2, 2. Yeah, I think that is a pretty optimal choice. So R equals 1 and O equals 2. That would make ROO equals 1, 2, 2. Okay, I think I agree with that. Now let's do the slightly more challenging part, figuring out what KAN and GA must be. So, all right, okay. Looks like we have some big digits. We have 9, 8, 7, 6, 5. First of all, how many of those digits do we actually need? Looks like we only need 4, K, A, N, and G. So it would be a good idea to make these digits 9, 8, 7, 6 in some order. Not necessarily in that order, but in some order, because we don't really need to use like 5, 4, or 3. If we did use 5, 4, or 3, we might as well just substitute them for a bigger number because we want to make them as big as possible. Okay, so now the question is, which digits should we assign to which numbers? Okay, Aaron's saying K equals 9. And I think that is a good idea. The reason why K is like super important is because K corresponds to a hundreds place. So like K being big means that we have a lot of hundreds, and hundreds are like more important than tens because they affect the total like sum more since they're like a bigger impact. 100 is bigger than 10. So I think it would be a good idea to make K equal to 9 because like if we made, yeah, because basically like K matters the most when we're adding KAN plus a GA because it's the only number that contributes 100. The other ones contribute like tens or ones since they're in the tens or ones places. Okay, so if K is 9, then for A, N, and G, we have 8, 7, and 6 left. Okay, let's see. So, oh, Arthur is saying K is 9, A is 8, N is 7. That's interesting. Okay, so actually, let's see. It seems like just like how K matters the most, if we look at N here, it looks like N doesn't matter that much, right? Because like, okay, N only shows up once, and it only shows up in the units digit. So among K, A, N, and G, it looks like N matters the least since like it's only going to contribute like some small units digit, which is like not very much. So I think maybe if we wanted to give any of these 4 a 6, it would be in our best interest to make N equal to 6 because like 6 is like the smallest out of 9, 8, 7, and 6. And so we want to assign it to the number that matters the least, if that makes sense. So yeah, N matters the least. And then, okay, now we just have 8 and 7 left to assign to A and G. So, okay, I think, wait, what have you guys been saying? It looks like people have been saying a lot of things. Rohan says G needs to be big. Okay, other people are saying A needs to be 8. So, okay, this is a little bit complicated because both A and G kind of like matter, right? Like they both matter quite a bit. G is in the tens place, and it looks like A is both in the tens place and in the units place. By the way, we're kind of like zooming in on this KAN plus GA part. So like just that box, just that yellow box. So, okay. Oh, now people are saying A must be 8. Okay, that's cool. So maybe let's examine exactly how much G and A matter. So G is in tens place. So that like matters quite a bit, I guess. And then A is in tens and units place. So actually A shows up 2 times. And that means that A matters a little bit more than G because they both show up in the tens place. So like they both kind of contribute like some number of tens, but then A also shows up in the units place. So A matters a little bit more than G. So if we wanted to set one of them equal to 8 and one of them equal to 7 to get the maximum possible sum, maybe we should set A equal to 8 and G equal to 7 so that A is bigger and basically like the bigger part like contributes more. Well, we want the bigger part to contribute more because then we're like getting the most out of that big number. So, okay, let's see. It looks like maybe this is our optimal like assigning of numbers to variables. So let's see, what would our result be? So if we set k equals k equals 9, a equals 8, etc., then we have that KAN is going to be 986, GA is going to be 78. So we're doing 986 plus 78 and then minus 122 because that's ROO. Okay, so what do we have here? 986, let's do it step by step. So 986 minus 78 would be 908 minus 122, I think, if I can do math correctly. And then, okay, wait, hold on. This seems a little bit suspicious. Wait, am I doing math correctly? Wait, hold on. Oh, okay. Wait, let me see what you guys are saying in chat because looks like people are saying interesting things. Okay, so Brenda said 986 plus 75 minus 123. Oh, oh wait, hold on. Maybe we did the question wrong and maybe different O's are like different numbers. Okay, that could possibly be our mistake because oh wait, hold on. Yeah. Oh wait, actually no, it says the same letters are replaced with the same numbers. So I think we did it right, but maybe we're just like wait, maybe I'm just doing math wrong. Hold on. Oh, okay. I see what's wrong. I accidentally subtracted 7, 8 instead of adding it. Okay. Whoops. Yeah, you guys are right. Okay, so we're all fine. We just need to I just need to do subtraction or addition better. So, okay. Let's see. 986 plus 78. This is what happens when you do too many steps in your head. But anyway, 986 plus 78 would be okay, 1064, I think. So 1064 minus 122. Okay, this looks better. Equals 942. Yay! Okay, and it looks like we got one of the answer choices. So that's always a good sign. Okay, hopefully this is correct. Hopefully 948 is not possible to achieve because if it is, then we messed up. But looks like you guys are saying it is choice D, so that looks good. Okay, let's see, is this correct? Yay, it is D. Yay, okay, that was a pretty interesting problem. Okay, so yeah, that is unfortunately all we have for today, but we're basically out of time anyways. So yeah, Haley, do you have anything to add?
Not really, but that was a pretty cool question, and it was really tricky because when I was thinking initially, I was like, wow, we just go 987 for KAN. So that was pretty cool.
Yeah, that was a really tricky problem. And it's always hard when you want to find the maximum of something because maybe you find what you think is the maximum, but there might be a better way to do it. Yeah, so that's always really tricky. Oh, Tia, you have a question? Since we have a few minutes, if anyone has questions, you can ask them in chat. And yeah, thanks for coming, everyone. But yeah, if you want to ask any random questions about anything in chat, you can stay. Oh, okay. Luca's saying, what side are you on for 0 divided by 0? 0, 1, or infinity? Wait, that's you can't divide by 0, so that's kind of weird. I'll have to think about that one. I feel like all of them would kind of make sense in their own ways. 0 divided by anything is 0, right? Anything divided by 0 is infinity. So, and then anything divided by itself is 1. So it feels like all of those kind of have some reason behind them. Oh, Evan is commenting something about calculus. Interesting. Okay. Yeah, 0 divided by 0 is kind of weird. Oh, Tia says your question was today algebra or I think today was a mix of different subjects. So oftentimes math competitions will have problems of a huge wide range of subjects. So we had algebra and combinatorics and geometry, all the different subjects today.
Wow, Eric is asking, what is this calculus rule? I feel like maybe we'll learn that some later day. Oh, but okay, maybe not today because it might be a bit complicated.
Yeah, if you want, you can search it up on Google.
Mhm.
Hospital rule or something that looks like that. Yeah. Oh, wow. Okay, Anthony, it looks like Anthony searched it up on Google, maybe? Oh, wow. Okay. That is one long chat message. Okay, wow. Yeah, that is pretty complicated and hard to understand.
Mhm.
But don't worry, we will not be using that rule in any of our live solves. Okay. Yeah, thanks for coming, everyone.
Mhm. Thank you guys.
Yeah, thanks.
Thank you.
Thank you. Oh, it seems like, okay, people are talking about 0 times infinity. Well, 0 times infinity should be 0, right? Because 0 times anything is 0. But I get what you mean. Like sometimes there are numbers that are basically 0, but not exactly 0. And we just like say they're basically 0. But if you multiply them